this video, we're going to look at going from logarithmic form and turning it into exponential form. So just as always, if you like this video, if this video helps you, like, subscribe, share it with somebody. So anyway, logarithmic form to exponential form, we need to learn two things first of all, or at least have a good idea of these two things. Logarithmic form looks like this. Log with a base b of a, so this a is right here, and this a is being plugged into this function log. So don't think that somehow this log base b is separate from this a, okay? And then that's equal to x. So equal to, we'll do it in this color. No, let's just do it like this, equal to x. All right, so now what we're going to do is take that and turn it into exponential form. And here's what exponential form looks like, and I'll try to use the same colors. So b to the x, because that's the base in our exponent, equals a. So now I tried to use the same colors so you can tell what matches up. So in our logarithm, we have this base b, and that's going to come over here and be our base of our exponent. We have this a, which is actually the part being evaluated. It's put into the function. That's going to be on the other side of our equal sign now. And then our x value over here is now going to be the exponent over here. So let's practice this a little bit. And this is a skill that's going to help us with the next video, actually. So let's start with, let's say, log base 3 of 9 equals 2. So if you're just starting out doing this, I recommend you go through and just label everything. So like we have our logarithm, that's log obviously. And now what is this little 3? Is it b, is it a, or is it x? Well, it's going to be b. All right, so then what's 9? Well, now we only have two choices, a or x, and that's going to be a. So then that means 2 has to be x. So now when we use b to the x equals a as our exponential form, it's pretty easy to plug in. So I know that at first logarithms, it sounds very difficult, but for right now, we're just rewriting this in exponential form. So we're not doing anything even with the logarithm. We're just learning how to rewrite it. So let's continue. So now we're going to say our base is now going to be this b, which is 3. X is our exponent, so 3 to the second, and then that's equal to a, which is 9. And as long as this turns out to be true, that means we probably did it correctly. So 3 squared equals 9, that is true. Now, here's what this whole process is trying to get you to understand. First of all, it's trying to get you to understand a couple different things. But the first thing is a logarithm. So a logarithm, it's just another way to write an exponent. So when you see logarithm, like if somebody comes into my class, they always look at logarithm and they're like, whoa, that must be something crazy. Essentially, if you put a logarithm into a calculator, it's just rewriting it as an exponent and then figuring out what that exponent would be, most likely. So the process for a logarithm, once again, is just another way to rewrite an exponent. Okay, so you can save yourself a lot of headache by choosing to look at it that way. So let's look at another one. Let's say log base 2 of 16 equals 4. All right, now you try this one. So see if you can rewrite this in exponential form. All right, so once again, I'm going to label everything just so you can see. So b is going to be 2. That's the base of our logarithm. And if you learn to read this log base 2, you'll literally tell yourself what the base is, all right? Because that's how this is read. You would say log base 2 of 16 equals 4. That's how you should read these, all right? Once again, that's helpful because it gives you the base right off the bat. All right, so now a is going to be 16, and then 4 is going to be x. So we're going to rewrite that as b to the x equals a. So 2 to the 4th power equals 16. And there we go. Let's do one more, and then we'll look at going the opposite direction. So, and actually we may look at more than one more. We'll see. All right, let's say I have log base 4 of 1 over 16 equals negative 2. Now, You may think, oh, there's a fraction, so this must be more complicated. But let's just go through and label everything. So 4 is going to be b. This entire thing is going to be a, 1 over 16, which means negative 2 is x. So if we rewrite this, we're not really changing anything. We're going to say 4 to the negative 2 equals 1 over 16. And if you remember anything about exponent rules, if we have a negative exponent, that means this would end up being 1 over 16. So this is all true. All right, so now this is useful for, and I guess this is kind of a tease for the next video, but this is useful for this situation. Let's say I told you, hey, I want you to do log base 7 of 49, and I want you to tell me what that's equal to. Well, if you make this x and you learn to rewrite this in exponential form, you could say 7 to the x equals 49. Now you could just look at this and tell me what x is. 7 to the second power would be 49, so x equals 2. Just like that, we were able to evaluate this. We were able to evaluate this logarithm without even using a calculator or using anything. So that's the whole point of doing this. All right. Now let's look at going the opposite directions, because sometimes it's good to go from exponential to logarithmic form. So now let's say I gave you 14 to the second power equals 196. And I want you to rewrite that in logarithmic form. Well, now we're just going to go to the opposite direction. Now we're going to take this and make it log base b of a equals x. So first of all, 14 is our b, that's our base. 2, remember if this is b to the x equals a, that means 2 is now x, which means 196 is a. So now if we rewrite it, log base 14 of 196, because a comes next, equals our exponent, which is 2. So that's how we could go the opposite direction and write this out. Now, this is more useful for solving some of the more complicated exponential equations, which we'll see. We'll see if we get there in this series of videos. Let's look at another one, and actually, we'll see. Maybe we'll call it a video after this. Let's see. Why don't you try this? 3 to the 4th equals 81. And see if you can rewrite that in logarithmic form. All right, so we would have log base 3, because that's our base, which is b, of, now we're going to do a, which is 81, equals x, which is our exponent 4. And it's that simple. So here's what I would do if I were you. I would just practice going back and forth between logarithmic and exponential form, just so you can get the idea of this down. Once again, in the next video, we're going to look at evaluating logarithms. And there's 2 ways we can do that, but one way is a lot easier than the other. So there are some basic examples where this is going to be super useful.